Hey everyone, in this video we're going to solve problem 3 from Superquiz 3. Here we're given a series, goes from 2 to infinity, okay, that's not too important, 1 over n cubed. So this is just a p-series, so we know it converges by the p-series test. Done. Oh, wait a second, we didn't read the problem. It says, use the integral test. Oh, okay, so I know what the answer is going to be, but I'm not allowed to just say p-series test. Bummer. Okay, well, what do we need to do to use the integral test? Well, we have to remember the catch. All right, so remember the catch. Check the hypotheses. All right, so what are the hypotheses for the integral test? So the hypotheses for the integral test are, well, first, we need to have a generating function for our sequence. So we need to have some function f of x, right, generating function for, in this case, 1 over n cubed. All right, well, it's pretty reasonable here. F of x should be 1 over x cubed, right? Whenever we're given a sequence in such an explicit format, the generating function is almost always just going to be take the sequence, replace all your n's with x's. Okay, cool. So we're able to do that. Check. Next hypothesis, it needs to be a continuous generating function, at least on the interval that we're summing over. All right, so it needs to be continuous on 2 to infinity. Sure it is, right? This is a rational function. The only place where, or I should say, f of x equals 1 over x cubed is a rational function. This is continuous everywhere except for 0, which is not in this domain. Okay, so this is continuous except at x equals 0. So check, we have continuity. Next, we need that f of x, right, is going to be non-negative, right, on this interval, 2 to infinity. Of course it is, right? 1 over x cubed is positive for x positive. All right, check. Final thing, it needs to be eventually decreasing. All right, so it needs to be eventually decreasing on 2 to infinity. All right, okay, well, we know a graph for f of x is going to look something like that. So it's definitely decreasing. If we wanted to test this very carefully, we could look at a derivative, right? So we could say, okay, what's the derivative of f of x? This is x to the negative 3, so this would be negative 3x to the negative 4, or negative 3 over x to the fourth. And x to the fourth, that's always positive, right? Because it's a fourth power. So this is always positive. So 3 over it is always positive. But if you put a negative, well, then it's always negative. So this whole thing is always negative, which tells you, if you have a negative derivative, right, that f is decreasing. Okay, again, assuming x is not equal to 0. Okay, so it's definitely decreasing on 2 to infinity. Okay, so we have checked all the hypotheses for the integral test, which means we can use it. Okay, what does the integral test say? Integral test says that this series, 1 over n cubed, converges if and only if the integral from 2 to infinity of the generating function, 1 over x cubed, converges. All right, but we just showed in the previous problem, problem 2. So by problem 2, this integral, I mean, we don't only know it converges, we know exactly what it converges to. This is actually equal to 1/8, right? i.e., it converges. Okay, so this is the integral test up here. Okay, and so by the integral test, we know that the original series, 1 over n cubed, converges. Bingo.